everyone, welcome back. Today we are starting with exercise 2.1. In the previous video, we saw the introduction part 2 to exercise 2.1. And if you haven't watched introduction part 1 and part 2, make sure to do so and get back here because that has like all the concepts that are required for this exercise. Okay, so let's start then without further ado for this exercise. So if you have your textbook, open your textbook up and a piece of paper and of course your device in which this video is playing. Or if you do not have your textbook, I have the PDF page right here as you can see. So from here itself we will solve it. Okay, so answers to exercise 2.1. Let's start with the first question. Which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. So let's start with the first part here. First part is 4x square minus 3x plus 7. So basically what do we have here? We have 4x square minus 3x plus 7. Now look at the powers here. Okay, here we have 0, here we have 1, here we have 2. It is a polynomial. Okay, yes, we can say yes, it is a polynomial. But can you tell me, my dear friends, why is it a polynomial? It is a polynomial. I've given you half answer, but why is it a polynomial? If you understood what is a polynomial, this will be absolutely easy for you. So polynomials are what? They are expressions that have whose variables have nothing but non-integral powers. Remember this word, non-integral powers, or you can say positive integral powers. Positive integral, what does integral mean? That means integers. Okay, non-integral or positive integral powers. Remember this key word, it is very important. Okay, this is the main part of the definition, right? So yes, it is a polynomial since all the powers are whole numbers, are positive integral powers. So you can say yes, it is a polynomial as all the powers are nothing but positive integral powers. You can also frame your own answer, but it must be apt. Okay, it must be correct. For this you can frame your own answer, not necessarily you need to copy mine. Okay, yes, it is a polynomial as all the powers are non-integral. Fine, this is the first question. You understood, right, what we are doing? Yeah. So now let us move on to the second question. Second part is y square plus root 2. Y square plus root 2. So is this a polynomial according to you? Look here. Now in this question they're saying which of the following expressions are polynomials in one variable and which are not. Look here, we are underlining the word variable, so you need to look only at the variables. Here 7, here x squared. So here you do not need to look at this x raised to 0. I'm sorry, we shouldn't look at this x raised to 0. We must only look at the variables. Here y square, here root t only, and here t, then here y, then all of these variables. You need to look at all of this. Fine, because they're asking polynomials in one variable. So according to this condition, look at this question. We are considering only y square, right? So y square, of course, it is nothing but a polynomial. So yes, because y square is having having power 2, which is a whole number, thereby it is a polynomial. We are only looking at the variables. Okay, so that is the second part. Fine. So now the third question is what? 3 root t plus t root 2. Now look at this. We need to look only at the variables. Now t is having proper power, right? But root t, always remember that any number or any variable which is having a root. Now when I'm talking about numbers having root, I mean the numbers which are not perfect, non-perfect numbers. I'm talking about those numbers. Okay, if a perfect square, let's say suppose root 9, if I take root 9 is equal to what, 3. So for those cases, what I'm going to tell you now does not apply. But suppose we have root 7, root x, and this root t itself. So what can we say? Root 7 is equal to 7 raised to the power of any variable or non-perfect number which is having a root can be always written as that number of variable raised to the power of half. Here it will be x raised to the power half, and then here root t will be equal to what now? Of course, t raised to the power of half. So now root t is equal to t raised to the power of half. So 3 root t is equal to nothing but 3 into t raised to the power of half. So we can say therefore no, as the power here, as the power here is in fractional form. That's why we can say that it is not a polynomial. It is in fractional form. Okay. Fine, I'm going to erase it here. I want to complete everything on this side itself, on the right side, because we have the textbook PDF here, and it might be convenient as well. So I'm going to erase all of this. Fine. Okay. If you haven't made notes, no problem. After I finish explaining, you can of course rewind the video. Okay. So yeah. Okay. So what is the next question? Y plus 2 by y. Let's not waste time. You think about it, whether y plus 2 by y is a polynomial or not. Come on, polynomial in one variable. Remember, we're talking about one variable. Okay, so I'll tell you why I'm highlighting that fact. In the coming questions, you will understand why. So did you think about it? I hope you thought about it. So we will anyway solve it. So first question, fourth one. Look here, y plus 2 by y. I told you we're looking at the variables. That means we're looking at this guy and this guy. So here y is having y raised to the power of 1, right? So this is okay, fine. This is accepted. What about 2 by y? Can I write 2 by y as 2 into y raised to the power of minus 1? According to a law of exponent, a raised 1 by a raised to m is equal to a raised to minus m, or it could be vice versa also. Okay, so this can be written as 2y raised to the power of minus 1. Sorry. So now you see this is a positive number, is it? Of course it is not, right? So can we say that it is not a polynomial? Of course, yes. So therefore, since, okay, therefore, since the power of y in 2 by y, or 2 into y raised to the power of minus 1 is negative, we can say that it is not a polynomial. It is not a polynomial. Okay, fine. Okay. So now let's move on to the fifth question, or the fifth part, whatever you want to call it. Then now x raised to the power of 10 plus y raised to the power of 3 plus t raised to the power of 50. Is it a polynomial or not? Look here. If I exclude this whole thing out of the question, then yes, I will say that this is a polynomial. Why? Because all the powers are positive integral powers, right? Yeah. So that is reason why we can say that yes, this is a polynomial if there is no statement like in one variable, but we cannot change the question. So according to the question, we have polynomials in one variable. And look at the question. Is there only one variable called as x or y or t? No, we have three variables. So what is the reason we can give for saying that no, it is not a polynomial? We can say that therefore, since there are, see, and you can change and write the answer as according to your own convenience, your own wish, but it must be right. Okay, you don't need to like copy whatever I'm telling you. Fine. Since there are three variables, since there are three variables, we can say that it is not a polynomial. And look here, we are moving on to the second question. Okay, so second question says write the coefficient of x squared in each of the following. So the first question I have written it here, 2 plus x squared plus x. So coefficient is what? The number along with the variable is what we call as the coefficient, right? If you've seen the previous videos, you would absolutely have all the ideas that what I'm talking about, what I'm talking about. Okay, so 2 plus x squared plus x. So here the coefficient of x squared is nothing but 1, because okay, it doesn't make any difference. 1 into x squared, 1 into x squared is nothing but x squared, right? Therefore, as I'm saying, coefficient of x squared is equal to 1. Second question is 2 minus x squared plus x cube. So here coefficient of x square is equal to minus 1, because here my 1 is already here, but we need to consider the sign along. So here it's a positive 1 in the first question. So it is a positive 1, which is nothing but 1 itself, but negative 1 is totally different, right? That's why we see coefficient of x square is equal to minus 1. Third question is pi by 2 x squared plus x. Now, what is the coefficient of x squared here? Coefficient of x squared is equal to pi by 2. We consider pi as well, okay? Don't consider pi outside. Fine. So pi by 2 is the coefficient. Fourth question is root 2, sorry, root 2 x minus 1. Okay, so root 2 x minus 1, they're asking for x square, and are you able to see any x square term here? No. So since you're not able to see any x square term, we will say that coefficient of x square is equal to 0. Why? Because 0 into x square, anything multiplied with 0 is what? 0. And when if you add 0 also, it's not going to make any difference here. So we will say coefficient of x square is equal to 0. Okay, so this is the second question. Let's move on now to the third question. Moving on to the third question. Give one example each of a binomial of degree 35 and of a monomial of degree 100. This is easy, right? Not very difficult, no? So what is a binomial? An expression containing two terms. What about a monomial? Expression containing one term. Okay, I hope you know this. Then now if you have to take binomial, you can go on giving infinite examples. So I'm only going to take one example out of my random choice. So here, like I'm going to take x raised to 34 plus y raised to 35. Look here, the degree is 35. Okay, then for 100 you can just write x raised to 100, or okay, 5x the whole, no, not 5x the whole, 5x, where x is raised to the power of 100 or etc. You can keep going on. So this is the third question. Let's move to the fourth question. So, okay, this is too light for you, I guess. Yeah. The fourth question, write the degree of each of the following polynomials. So the first question is 5x cubed plus 4x squared plus 7x. We need to write the degree. What is the degree? The highest sum of the variables of each term in an expression is called as degree, right? So now, what is the degree then? So the degree is nothing but 3, because look here, in x we have 1, here in this x we have 2, in this we have 3. So the highest power is what? 3. Therefore, degree is 3. Second question is nothing but 4 minus y square. Now 4 into y raised to the power of 1, and then, no, not y raised to 1 actually. You can't write that. We need to write 5 into 4 into y raised to the power of 0 minus y square. So this will be nothing but 4 minus y square, right? So therefore, now we can say that the degree is nothing but 2. Degree is 2. Okay. So next, moving on to the third question. Third question, which is 5t minus root 7. So now here t is raised to the power of 1, and here if we raise t raised to the power of 0, we will get root 7. So here degree is 1. Fourth one is nothing but 3. So what is for 3? 3 into x raised to the power of 0. So the degree is equal to 0. So this is the fourth question. Let's move on to the last question of this exercise. Hooray! You're happy, right? Then I'm happy we're coming to the last question. Let's move on. So coming to the last question now. What does the last question say? Classify the following as linear, quadratic, and cubic polynomials. So we need to classify all these into linear, quadratic, and cubic. Okay, so first one is x squared. Okay, I won't write the question again, but you look at the question here. I will just write what polynomial, what type of polynomial it is. Okay, so for the first one, linear, quadratic, and cubic polynomials, you know what are they? Okay, so when in a polynomial the degree is 1, we say that such a polynomial is linear. If it's quadratic, degree will be 2. Cubic will be 3. Okay, so for the first one, it is quadratic. Second one, it is cubic. Third one, okay, one sec. Third one is nothing but quadratic, right? So quadratic. Fourth one is linear. First time linear is coming into picture. Huh? Fifth one is linear again. So sixth one is quadratic. Seventh one is 7x cube, which is nothing but cubic. Okay, so I hope you've understood this exercise. That's it for this video as well as for this exercise. So I hope you enjoyed this and you found it useful. So I will see you all in the next video with the introduction to exercise 2.2. I will tell you in the next video how many parts it will be for exercise 2.2. If it's long, I will divide it into parts. I will tell you about that in the next video. Until then, take care of yourself. Stay safe during the pandemic. God bless you. Bye guys. Bye for now.